Determine if the ODE is exact. If yes, find f of x comma y. So we actually looked at this previously, but I never actually solved it. So we're going to go ahead and just solve it right now and go through the steps. And so first thing we need to do is identify the m Mars for m of x comma y and the n Neptune for n of x comma y. So the Mars of x comma y is the part not attached to y prime, and then the stuff attached to y prime is the Neptune of x comma y. All right, and so the test is, does partial Mars partial y equal partial Neptune partial x? All right, and if that's true, it's going to be exact. If it's not true, it's not exact. So let's go ahead and compute those. So we have partial m partial y is equal to partial y applied to the m there. So that's the 14xy cubed minus e to the x. So 14xy cubed minus e to the x. Okay, well that ends up being, let's see, so 14x, they stay the same. The y part will take the derivative of, the 3 pops down. 3 times 14 is 42. The x stays the same because it's a partial derivative with respect to y. And then the y cubed turned into y squared. And then partial derivative with respect to y for e to the x is just 0. So it's a minus 0. And then we have next partial Neptune partial x equals, okay, partial x applied to up here, let's see, 21x squared y squared plus cosine y. So 21x squared y squared plus cosine of y. All right, so partial x applied to 21x squared y squared. The x squared will pop down to 2, so 2 times 21 is 42. The x squared turns into x, and the y squared stays as it is. And then partial derivative of x applied to cosine of y, that's 0. There are no x's in here, so that's a plus 0. And yes, they do agree. So, back up here, yes. So now from there, we know that f of x comma y exists. So now we're going to find it. So back in our triangle, or diamond here, we have m of x comma y plus, Neptune of x comma y, Mars of x comma y plus Neptune of x comma y, y prime equals 0. Right, and we have our f of x comma y equals a constant. And so to get from here to here, we took the derivative with respect to x. So then to go back from m to f, we're going to take the integral with respect to x. And same thing on this side, to get from f to n, we took the partial derivative with respect to y. So to get back, we're going to take an integral with respect to y. All right, so let's get started on that. So f of x comma y is equal to the integral of m of x comma y dx. Okay, well that's the integral of, going back here we go, 14xy cubed minus e to the x. So we've got 14xy cubed minus e to the x, and then there's a dx on the end. All right, well let's see, so 14x cubed, so x will turn into x squared, and it will take a 2 out of the 14, so that 14 will turn into a 7. The x will turn into x squared, and then y cubed stays the same. And the minus e to the x stays just minus e to the x. The antiderivative of e to the x is e to the x. But keep in mind that there could be, the constant integration here could include constants, but also y's. So we have this unknown function, h of y, that we might have to get to agree with this other path here, going from Neptune to f. All right, so going on the Neptune path to f of x comma y should also equal the indefinite integral of Neptune of x comma y dy. Okay, well Neptune was way back here, 21x squared y squared plus cosine y. So 21x squared y squared plus cosine of y dy. All right, well, let's see, 21 let's see, the y squared will turn into y cubed, and it'll take a 3 out of the 21. So that's going to turn the 21 into a 7. X squared stays the same. And right, the y squared turns into a y cubed. Things are looking good, right? I have 7x squared y cubed here. There's a 7x squared y cubed here. And I have my plus cosine of y. Well, the antiderivative of cosine is positive sine. So we're going to have just a plus sine of y. And then same thing over here, we had this h of y, because this kind of, when we took the partial derivative with respect to x, there could be some y stuff that disappeared that we have to keep in track of when we integrate back up. Same thing here, we're going to have this g of x function in case there was some x stuff that disappeared when we took the partial derivative with respect to y, to get from f of x comma y to Neptune of x comma y. All right, so these have to be equal. So far, things are looking good. So I have this common term here of 7x squared y cubed, 7x squared y cubed. And then I have a negative e to the x, but I can match that with this plus g of x. So g of x is negative e to the x. So I have a minus e to the x. And then I've got this h of y, but I can match that with sine of y. And I have plus sine y. And that's all going to be equal to a constant.